We have units of concentration to represent how much solute is contained in a solution. Molarity is something that we already know. Molarity is moles of solute in every liter of the solution. And we use capital letter to represent a molarity as the unit of concentration. If you have a solution and the label reads 2.0 capital letter M NaOH, it means that the solute is sodium hydroxide and you have 2 moles in every liter of that solution. Another unit of concentration is molality, and for this one we use lowercase letter m, and molality is the moles of solute divided by the kilograms of solvent. So I have an example here to calculate the molality of a solution, and the point of going over this unit of concentration here, molality, is because when we go over colligative properties, whenever we want to calculate anything involving the equations for colligative properties, the concentration for the solutions is going to be given as a molar concentration. So going through the problem, I have 6.44 grams of naphthalene and 80.1 grams of benzene. The first thing that you have to do is to identify which substance is your solute, which substance is the solvent. Remember that when you have your solution, the solution is composed of solute and solvent. The solvent is the part on the solution that is doing the dissolving. So the solvent is in a greater quantity. So when I'm looking at my numbers, I can determine based on the amounts that are given that the benzene is going to be the solvent for the solution. So naphthalene is going to be the solute. If you want to calculate the molality, you need the moles of solute. The amount of solute is given in grams, and you have the formula for your solute, which is the naphthalene. So you can find out the molar mass of naphthalene, and then you can convert your grams to moles, so you can have the moles of solute to plug in into the equation. The other thing is that for you to calculate the molality, you need the kilograms of the solvent. The amount of solvent that you have is given in grams, so you have to convert your grams to kilograms so you can get the final answer. So to find out the number of moles of solute, which is naphthalene, I need to convert grams to moles by dividing by the molar mass. Okay? So you can calculate the molar mass, just an approximation. I have 10 carbons, each one is 12. The molar mass for carbon is 12 grams per mole. And then I have 8 hydrogens, okay, and it's the molar mass for the hydrogen is like 1.01, and you have 8 of them. So adding everything together, you should get something close to 128 grams. So you can calculate the number of moles, 6.44 times 1 mole divided by 128 grams. 0.0503. I'm rounding the number that I'm getting from the calculator to 3 significant digits because I have my given amount here in 3 significant digits, so I'm keeping 3. And then you have your the mass of the solvent, which is the 80.1 grams. If you want to convert grams to kilograms, in every kilo you have 1,000. Now I have the numerical values that I need to plug in into my equation to calculate the molality. Okay? I have the moles of the solute, I have the kilograms of the solvent, so moles divided by kilograms is going to give you the final answer. So the molality is going to be 0.0503 mole over 0.0801 kilograms. 0.6280, 0.628, and that's lowercase m for molality, which is the same as saying 0.628 moles in every kilogram of that solution. The third unit of concentration that I have listed here is the mole fraction. For mole fraction, we use this symbol here as an X, which is going to be moles of A, and this is just a fraction, so it's moles of one specific substance divided by the total number of moles that you have. So I have an example here. I have that you're preparing a solution with 2 moles of A, and you have 8 moles of water, which is the solvent. And this is asking you to find out the mole fraction for A, which is the solute, but also for B, which is the solvent in the solution. So if I want to find out my mole fraction here for A, that's going to be the moles of A divided by my total number of moles. The moles of A is given, that's 2. The total number of moles in this solution, this specific example here, you have the solute and water, nothing else. Okay? So the total number of moles is going to be the addition of the moles of the solute plus the moles of the water that you have in your mixture. And that's it. So 2 moles of A and 8 moles of your solute, that's going to give you a total number that is 10. So you have the 2 moles divided by 10, that's going to be 0.2. And that's the molar fraction for A. If you want to find out the molar fraction for the water, is the moles of water divided by the total number of moles. So the number of moles of water is 8. The number of moles that you have in total is 10 because you're adding the 8 moles for water plus the 2 moles of 8 together. So when you do 8 divided by 10, that's going to give you 0.8 moles of, as the molar fraction, no unit. Okay, so it's not 0.8 moles, it's just 0.8 because the units are canceling out. This is a fraction, so you should have the same unit on the top number and the bottom number in your fraction, and the unit will cancel out and you're just getting a numerical value at the end.